Lesson 7's Z-score. So Z-score tells you how many standard deviations you are away from the average, and it also helps you find the percent of data. So we use the formula Z equals X minus the mean divided by the standard deviation. So that's your Z-score. So for our first example, we have a runner who's run in 2 races. You have an average of the club, so the running club, and a standard deviation, and X, which is your run. And you want to see how this compares to each other. So how good is the run away from the average? So we're going to do 2 calculations. So first is Vancouver. So we have Z is equal to X minus the mean divided by the standard deviation. Our X is 25.45. The mean is 25.75. And the standard deviation is 0.62. And when you type that into your calculator, you should get negative 0.484. So that's how many standard deviations you are away from the mean. For Lake Louise, I'm just going to put LL. Your X, so we write out our formula. Our X is 24.77. The average is 25.52. And the standard deviation is 0.60. And if you type that in, you get negative 1.33. So if you were to imagine this normal curve, and you have U, and here's your standard deviations. This is 1, 2, and 3. The other directions is negative 1, negative 2, and negative 3. And we want to place our numbers in, so Vancouver is here at 0.482, and Lake Louise is here at 1.3. So if you're to look at the data, because you're going to the negative, which means you're running the race quicker, Lake Louise is farther away from the mean. So that means Lake Louise, you did faster, had a faster run. So because it's farthest away from the average, that means it's just that much quicker than the average. If it was going this way, it would mean you were slower than the average. So Lake Louise is the better run. IQ scores are normally distributed with a mean of 100, a standard deviation of 15, and if a person scores 119, so that's our data, how does this score compare with the scores of the general population? So what we're going to do is we're going to calculate our Z-score. So Z equals X minus the average divided by theta. Our X is 119, our average is 100, and our deviation is 15. When you find this as a decimal, you get 1.27. So that means that on our little chart, our normally distributed graph, here's the average, here's one deviation, 1.27 is in here. So what we're going to do is you're going to flip to the Z-score chart. So this is going to tell us the percentage to the left. So your Z-score chart should look like this. And we're looking for a positive. So if you go, this is how you read the chart. We're looking for 1.2. So we go to 1.2. And our next decimal place is a 7. So you're going to follow the chart all the way down to 7. So this is the piece of data we are looking for. So the percent is 0.8980. I'm just going to delete the chart so we can see. So what that means is 0.89080. If you times that by 100, you get 89.80, and that's a percent. So that's this percent, everything to the left of the data. So what that really means is that a IQ score of 119 is higher than 89.8% of the general population. Run out of room. Okay, there you go. So an IQ score of 119 is higher than 89.8% of the general population. Part B says we want to find to the right of the curve. So we want to find this. So what you should know is that the entire thing is 1, or 100%. So if you take 1 and you subtract the number you found from the table, this will find the percent to the right of your data. So this should equal 0.102 times 100 is 10.2%. So what that means is that 10.2% of the general population is higher than a score of 119. So only about 10% is higher than 119. So if you're in 120, you're in the top 10% of the general population. So example 3 is using the same information. So we have the average is 100 and the standard deviation is 15. We want to find the percent between an IQ of 75 and 115. So we have to find the z-score of each piece of data. So we'll do 75 first. So z is equal to 75 minus 100 divided by 15. You should get 0.0475. For x to be 115, we take 115, subtract 100, divided by 15, and you get 0.8413. Okay, so sorry, I missed a value. So let's just redo these last lines. So when you divide this, you get negative 1.67. So we need to find the percent on the chart. So if you look at the chart and you go to negative 1.6, we want to find 67, you get 0.0475, and that's what I had written before. I just wasn't paying attention. Sorry. So now we're going to do it with the other number, and this equals 1. So we go to our chart. We're looking for 1.00, which is 0.8413. So we have our 2%. So if we were to sketch the normal distribution, this is our mean. We have one value, which is the red value, at negative 1.67. And this is the same as 0.0475. And our top value is 1, which is 0.8413. And we want to find the percent in the middle. So the way that we do that is we take blue, oops, oh, it's purple. So blue, so the area of our maximum, and we're going to subtract the area of our minimum. So that will be left is the green area, so between the 2 points. So you take your maximum and you subtract your minimum. So 0.8415 subtract 0.0475 and you get 0.7938 times by 100, you get 79.38%. So to write your final sentence, 79.38% of the general population has an IQ between 75 and 115. So there you go. Okay, last example. Running shoes lose their shock absorption after a mean distance, so a mean distance of 640 kilometers, with a standard deviation of 160. You are a high-performance runner, so you want to replace your shoes after 25% of people replace their shoes. So we don't know our X. We want to know when to replace your shoes. So if you were to sketch your normal distribution, you want to be here. So this right here is 25%. So we want to find our Z value with a percent of 0.2500. So we're working backwards now. So what you need to do is you need to get your Z score chart. And we're on the left side, so you need your -1. And what you're going to do is you're going to look for a number that has 0.2500. So the closest that I can find is right here. So it's not exact. So at -0.677, just 67, you have 0.2514. And at -0.68, you have 0.2483. So we know that the Z score with a percent of 25% is in between these two values. So we want to use Z to equal 0.675 negative. So right in between those two numbers. So because it's not exact, you need to use both numbers to make it as precise as possible. So we're going to plug this all into our equation. So Z equals X minus U over theta. And our Z is -0.675. We don't know our X. Our mean is 640, and our theta is 160. Not theta, our standard deviation. It's not even a theta. I just lied to you. So what we're going to do now is we're going to isolate X. So we're going to multiply both sides by 160. This cancels, so we have 160 times -0.675 equals X minus 640. That doesn't look like a 640. There we go. And now we're going to add 640 to both sides. So 160 times -0.675 plus 640 is equal to X. And you should get 532. So if you want to make a note of it, the formula, once you've manipulated to find your X, is Z times your standard deviation plus your average. So I just made a little note of that on my page. You can always solve for X, though, using your original formula. So what this 532 means is after 532 kilometers, you change your shoes. So that would be right here. This is 532 km.